Assalamualaikum and hello to all. We are going to study chapter 4.2 limiting reactant theoretical and actual yield, also percentage yield. So learning outcome. At the end of the lesson, you should be able to define what is limiting reactant, theoretical, and actual yield, percentage yield. But today we are going to learn about this one first, only this little part here, yeah, limiting reactant. Okay, limiting reactant. What is limiting reactant? It is the reactant. So if you have A plus B forming C and D, we are only referring to this thing because this thing is reactant. C and D is product, right? So limiting reactant is reactant that completely consumed at the end of the reaction and limits the amount of product formed. So is it A limiting reactant or is it B limiting reactant? Okay, so it can be either A or it can be B, depending on the number of mole or the amount that exists in the reactant. Okay, so let's proceed straight away to exercise. So let's see this example. If 4 mole of S react with 10 mole of F2, which of the two reactant is the limiting reactant? Okay, so S react with F2. So which one is the limiting reactant if you have 4 mole of S and 10 mole of F2? So let's see this equation. So 1 mole of S can react with 3 mole of F2. So if you have 4 mole, okay, given 4 mole for you of S, it will react with 10 mole of F2, right? Wrong. This is wrong. This is wrong. Okay. What is given for you here? 4 mole here is what we call number of mole available. Okay, sometimes also called N given lah, number of mole given. Available. Salah eja pula. Available. Okay, available. So this one also the same. This is number of mole of F2 that is available. Okay, so that is available. That is what is given to you. But it is not stoichiometrically correct. It can be stoichiometrically correct, but you need to confirm whether it is stoichiometrically correct. Okay, so let's try to solve this one again. Okay, so 1 mole of S actually can react with 3 mole of F2. Okay, so if you have 4 mole of S, how much it will react with F2? Is it 10? Is it 10? 10 is available. 10 is what is given to you. Okay, if I draw, so it means that if you have a beaker, you put sulfur 4 mole and you put F2 that is 10 mole. So we want to know which one is the limiting reactant. Okay, this number means that what is available to you. What is available to you. So cross product this one. So back to the equation, cross product. 1 times X, X times 1, the same thing. So 3 times 4, so 3 times 4. Okay, so X is actually equal to 3 times 4 over 1. So it is 12 mole. What is this number that you calculate? So it is X. What is X? X is mole of F2. Okay, so here you can see that stoichiometrically, when you have 4 mole of S, it will react with 12 mole of F2. Okay, let me just write down again. So 4 mole of S actually will react with 12 mole of F2. Okay, so 12 mole here is the N calculated. Okay, N calculated, or sometimes we also write down N needed. Okay, it's the same. Okay, N calculated or N needed. N is referring to the number of mole. Okay, so which one is limiting reactant? Is it S or is it F2? So you need to use this data to write something like this. Okay, what we see is that number of needed, number of mole that you calculate, this one, number of mole of needed, F2 is larger than N available, F2 available. Okay, so N available here referring to this number, 10 mole. So it means that, the N available of F2 is not enough to react, to fully react with 4 mole, 4 mole of S. So what happened? You need 12 mole, but what is available to you is only 10. Okay, so F2 is the limiting reactant. It is the limiting reactant. Okay, so how do we know F2 is the limiting reactant? Okay, back to the definition. It is completely consumed. Okay, completely consumed. So in this case, you have 4 mole of S. You have 4 mole of S. You need 12 mole of F2, but you only have 10 mole. Okay, so 10 mole actually can react all of it with 4 mole. Okay, 4 mole of S. So F2 is the limiting reactant. So F2 is the limiting reactant because it is fully consumed first. Okay, it is fully consumed first. Okay, let's see exercise 2. So given for you the equation, so the data is also given, the mass and the atomic and molecular mass. So let's identify the limiting reactant. Okay, so aluminium and ferrum, we need to find the stoichiometry first, the relationship in terms of stoichiometry. So 2 mole of Al will react with 1 mole of Fe2O3. Okay, so what you need to do is you need to find the number of mole from the mass that is given, because you cannot compare using gram. Al and 601 gram. Okay, this is wrong. You cannot compare with mass. Yeah, you need to compare with mole. So we need to find the number of mole. So number of mole of Al, which actually refers to number of mole of aluminium available, equal to mass over Mr, which is 124 gram, over Mr, which is 26.98 gram per mole. The unit will be cancelled off. So the answer for this one is 4.67 mole. And number of mole of Fe2O3, this one, mass over Mr, available, or what is given to you, mass over Mr, 601 gram over Mr, shown here, 159.69 gram per mole, cancel off. So this one I have recalculated. It is actually 3.76 mole. Okay, so now we can relate. Again. So 2 mole of aluminium will react with 1 mole of Fe2O3. So Al available is 4.67 mole. So if you have 4.67 mole of Al, this will react with 3.76 mole, right, of Fe2O3. 3.76 mole of Fe2O3. Okay, this is the common misconception that students have done. No, you cannot compare N available with N available. Okay, so this one is wrong. This one is totally wrong. Okay, let's erase this one. I need to tell you this because in marking the student exam paper, there is a lot of misconception and you will lose mark. And that relate to your future, right? So I'm going to tell you how to do it properly. So 4.67 mole, this is an available of Al. And this one we don't know. Okay, we don't know actually how much you are going to need if what is available to you is 4.67 mole of Al. So cross product as always, 2 times x equal to 4.67 times 1. So x equal to 4.67 times 1 over 2. So this one is 2.34. Okay, the number here, what are you calculating? It is x. When what is x? Mole of Fe2O3. Okay. So you need to compare. So N needed of Fe2O3. Okay, N needed refers to what you calculate. Is 2.34 mole. Okay, whereby N available for you of Fe2O3 is this one, 3.76. Okay, so we can do comparison, which means that N needed is lower than N. N needed for Fe2O3 is lower than the amount of N available that is available for us. So it means that you have a lot of Fe2O3, but what you need is only a little amount, 2.34. So it means that Fe2O3 will react with Al, whereby Al will be fully consumed. Okay, so if we were to imagine you are the Al, okay, you are aluminium, and you are hungry, so you are only able to eat 2.34 plate of rice, but what is available to you is 3.76. So how much you will eat? You will only eat 3.74. So you are the limiting reactant. You limits what is being consumed. Okay, so in this case, aluminium is the limiting reactant. Okay, aluminium is limiting reactant. Okay, so that's the calculation for it. Okay, next one, exercise 3, more exercise. Okay, equation is given. So you need to determine A, limiting reactant, and B is the mass in gram. Okay, so let's try to answer this one first. So as always, write down the stoichiometry first. So 1 mole of zinc will react with 2 mole of HCl. Okay, so HCl, we know what is available, 0.18. Okay, so we know what is available. So number of mole of HCl available is 0.18 mole. But what about N available of zinc? Okay, this one you need to calculate using mass over MR. So mass is already given to you, which is 10 gram. So 10 gram over MR also given 65.38 gram per mole. Cancel. So your answer should be, I already calculate this one. 0.153 mole. Okay, so now we get both of the data. So I will write down again. So 1 mole of zinc needs to react with 2 mole HCl. So if you have this time I take this one. So if you have 0.18 mole of HCl, okay, what is the mole of zinc that you need? Okay, again, this is the number of mole that we need to calculate. So this is an available. An available. Okay, an available. Do not write down both of this side is an available. Okay, one must be an available, one is X the one that you are looking for. So cross product as always, 2 times X equal to 1 times 0.18. 1 times 0.18. So X is equal to 1 times 0.18 divided by 2. So this one is actually 0.09. 0.09 mole. Okay, so what are you calculating? So you are calculating the number of mole of zinc. Okay, of zinc. So the value that you calculate here, because you calculate, this is n needed or n calculated. Okay, now compare the value. So number of mole needed of zinc, okay, if we were to compare with n available of zinc, this is 0.08. This is n available. Okay, this is n available, which we need to put here. Okay, n available. So is it larger? 0.08 needed. Is it larger or lower? Lower, right? Okay, so when it is lower, again, just imagine if you are the one who eats, okay, you only need 0.09, but what is available to you is 0.153. Okay, you are the limiting reactant. You are going to eat 0.09. Okay, even though there is a lot more of the zinc that is available. So it means that you, the HCl, Zn is the rise, so you are the limiting reactant. So HCl is the limiting reactant. Okay, so that is about limiting reactant. Okay, I hope you get the idea for this one. Okay, and HCl is the limiting reactant. This value you need to remember because we need to answer the second question. Okay, let me erase this one. So second question. So limiting reactant, we have decided it is HCl. The mass ingredient for hydrogen gas produced. Okay, for this one I need to write down something for you. Okay, for comparison with products, use stoichiometry with limiting reactant. Okay. Okay, so what I mean here, we want to find the mass of the product. Okay, the mass of the product here. So there are two reactants, zinc and HCl. So for you to use the comparison from the stoichiometry, you need to use the one which is the limiting reactant. So the one with the limiting reactant is this one, HCl. So your comparison is 2 mole HCl react with, produce 1 mole of H2. Okay, 1 mole of H2. Okay, so HCl is the limiting reactant. So the number of mole is already given, 0.18. So you just write down 0.18 mole of HCl. How much will it react with, how much will it produce H2? So again, cross product 2 times X, 2 times X equal to 1 times 0.18, 1 times 0.18. So X is equal to 1 times 0.18 divided by 2. Okay, so X equal to 0.09 mole. Okay, again, what is X? X is mole of H2. Okay, so now you get the mole. Why do you need to find the mole? Because for you to find the mass, you need to relate to the mole, right? Because mole is only thing that you can relate to stoichiometry. So mass of H2 is equal to number of mole times MR. MR given of H. This one is not H2, but H. So 0.09 times 2 times 1.00 gram per mole. So calculate using your calculator and you get it is actually 0.18 gram. Okay, so that is how to answer question B. Okay, so after this, try to do some exercise about this topic and good luck. That's it. Bye.